Hello
Hi-
there.
Hey, hi, Aris. How are you doing?
I'm not bad. How are you?
I'm good. Really good to see you.
Yeah, it's been a while. We finally got to do this. It's great.
Oh yeah, indeed. How have you been though?
Yeah, I've been good. I've been good. It's a day off today, so just been trying to catch up with a few things, try to set up a few other podcasts. But yeah, it's great. Always keeping busy.
Uh,
That's the way forward. What about yourself?
oh yeah, it's been all right actually. I'm still working from home, so I've had to give like lectures from my house. So yeah,
Yeah,
not too bad, but I try to get out there just for a bit of exercise and stuff. So yeah, wishing for the best now.
yeah, it's important to kind of get out there, isn't it? Especially with the second lockdown now. Everyone.
Oh yeah. But a bit of positive news about the vaccine yesterday
Yeah,
potential. So
yeah. Hopefully
we'll
that's
have to wait.
its way.
Yeah. Nice. Oh well, there we go.
Fantastic. So, shall we get started?
Oh yeah, sure.
Awesome, awesome. So I just want to say thank you for coming on and a big welcome to
Yep.
History Talks.
Yeah.
It's fantastic to have someone from your background on.
Okay.
Yeah, so one thing I'd like to kind of start with is obviously just introduce the listeners of who you are and what do you do.
Okay. Yeah. So I'm Ade. Officially Dr. Adeayo Sotayo. I'm a researcher in additive manufacturing based at Brunel University London. So I actually did my degree in mechanical engineering at University of Liverpool. I noticed you
Yeah,
went to Liverpool as well.
yeah,
So
university graduate.
yeah. So I did my undergraduate there, then went on to do a PhD at Lancaster University, still in engineering, and went back to Liverpool for a postdoctoral research role. So then before coming to Brunel. So currently I'm working in additive manufacturing. So yep, that's a bit of a summary about my background.
Fantastic. It's an awesome city, is Liverpool, isn't it? I do miss it at
Oh.
times.
Oh, have you left then? Are you in a different city now?
Yeah. So I'm a different city now. I've moved to Manchester for work now, so not too far
Oh,
away, but still another great
yeah.
city. But yeah, Liverpool is awesome.
Yeah, I love Liverpool. So yeah, I still go back. So yeah, I go
Yes.
back up.
Same. So would you like to kind of highlight kind of what attracted you to kind of go into the additive manufacturing world?
Okay.
And
Oh, so if, there's that's that's due to a number of reasons. First of all, like it's something I've always heard of as a developing technology. Like now everyone is talking about AM, well, more commonly 3D printing, and this is something I've been interested in. And it's also more because I have a background in engineering, which was focused on materials and manufacturing processes. And I've always come across 3D printing as one of the ways you can use to make things. So it was more from a sustainability point of view. It was beneficial. It had different advantages. And it just seemed like one of those core components for like Industry 4.0. I don't know if you've heard about that. It's just about how to make things more interconnected and more automated. So yeah, the plethora of advantages really in that field. So I said, why not?
yeah, fantastic. We're going to highlight.
Yeah.
We're going to discuss a little bit that further in a second. But for everyone listening, you kind of touched on a little bit there, but the aspect it's 3D printing. Could you
Yeah.
explain to us a little bit more about additive manufacturing and how it works in the best kind of
Oh,
layman's terms?
okay. Yeah. So from a very basic view, so additive manufacturing, also commonly called 3D printing, is a manufacturing process that actually involves designing an object or a product with the CAD software, which is then subsequently built by adding materials layer by layer. So in essentially a digital design into a physical product by adding the materials layer by layer. So that's the layman definition of additive manufacturing or 3D printing.
Yeah, it's crazy. After doing a bit of research into this, like the potential for this technology is like limitless. It's like you see, so from basically kind of using of like you can make simple toys in America. Some people there's been a bit of concern about people making guns with it, but in
Yeah.
China, people have been making houses with it. It's so crazy how this technology is rapidly accelerating and where it can potentially go.
Yeah.
Um, one thing that's quite interesting as well is the different types of 3D printing and how they work. Do you want to kind of highlight a little bit of that to us?
Oh yeah, so actually according to like the ASTM standards, there are actually 7 major types of additive manufacturing, or 7 major processes. But these are broken it down into different, but I'll explain that. So the 7, I'll start with material extrusion. That's like the most common method, and sometimes called fused deposition modeling, or fused filament fabrication. So essentially, it means when a material is selectively dispensed through a nozzle.
Right.
So that's the most common one. That's the one you would usually see, for example, in academic institutions and stuff. So that's one process. Then there's one called a material jetting. So one thing, first of all, jetting essentially means like spraying. So that's it's essentially when droplets of build material are selectively deposited. So that's another one. And there's one called binder jetting. So binder jetting is 2 major materials, which means you're using a powder-based material and a binder. So the liquid bonding agent is selectively deposited to join powder materials. So that's the third one. Then there's something called directed energy deposition. So it's from 2 sources. So that's the energy and the material. So it's where thermal energy is used to fuse materials by melting them as they are being deposited. So that's another process of AM. Then more commonly, you also have the powder bed fusion,
Right.
still using thermal energy. So this thermal energy can include like laser, electron beam, where it actually fuses regions of a powder bed to make products. So more commonly, you might have heard of like selective laser melting, SLM, or selective laser sintering. These are all subsets of powder bed fusion. There's also something called a VAT photopolymerization. This is quite this was one of the early processes where it involves a liquid photopolymer in a vat. Essentially, that's like in a vat being like a top, essentially, is selectively cured by light activated polymerization. So one of the benefits of this is like good surface finish, and more commonly you might have heard of it as SLA, or digital light processing, where the difference is the light source. And finally, you also have something called sheet lamination. So before I explain, this is more like if you think of like timber laminates, like a glue lump beam. And so it's essentially where sheets of material are bonded to form a part. But those are like the 7, according to the ASTM standard, those are like the 7 major processes of additive manufacturing.
So in the aspect of, because what we're seeing now generally, for people that kind of know about 3D printing, the most common thing that they'll probably see right now is the people who have 3D printers in their house and they use it to make things. What type of additive manufacturing is that then?
So I think a lot of that is material extrusion.
Right. Yeah.
So that is, a lot of that is mine. So which is when a material is selectively dispensed through a nozzle. So you see the nozzle moving. Think of it as the XY plane moving, and that's commonly material extrusion.
Right. Fair enough. So one thing is that obviously it's quite prevalent in multiple industries as well at the minute. And one of the industries I've seen from my research is where it's very prevalent is the medical industry.
Is what? Sorry?
Sorry, one of the industries where I see it's very prevalent right now is the medical industry. And like, so we're seeing it's one of the key things for dentists, and it's very key for them to be able to formulate the aspects of not braces, but the aspects of dentures, and be able to formulate them a lot quicker. And even further beyond that, we're seeing it now. I saw some articles where 3D printers can be used to make hearts. So it's fascinating where we can see this technology go. Would you say this technology in this particular sector, it's the early adoption phase? Is it the booming phase? Whereabouts would you say it is at the minute?
I think based on those examples you've already listed, so it's certainly it's being adopted. It's not in the early stage. It's being actually used proactively. And I'll give you some examples. Like you mentioned the 3D printed, that 3D printed dentures that are used by dentists. And why this is being used comes from that customization. So now you can actually make parts that are patient specific. So you have developing science that uses like as a raw material, that uses cells, tissues, and biomaterials as a raw materials to make, like from an anatomical perspective, our parts are reasonably complex. So 3D printing can help make that a reality. So we not only that, you also have things like 3D printed cast. That's because if I got injured, like different patients have different needs, and 3D printing can actually get you can make casts that are suitable for a particular person. So that's why it's being adopted proactively. And you have like the human heart models and other parts of the humans. Apart from that, the 3D printing being used in the medical industry. If you think of the current pandemic, 3D printing became a major aspect of it. So you have 3D printing being used to make like test swabs, check for patients if they've got coronavirus, face masks and face shields. And essentially, one of the benefits is still the customization. And secondly, you're able to help decentralize manufacturing. So for example, 3D printing became useful because in unexpected situations like this, there were hospitals that actually had like 3D printing hubs, which was co-located in hospitals where you can actually make parts for patients. So this highlights the remote accessibility and adaptability of this process. So finally, just before you ask your next question, it's also used as a visualization and training aid. So for example, if I was to make like a complex part of a human, like the heart, for example, I could 3D print it and then use it to explain things. So it's used as a visualization aid for you to understand things properly. So it's being adopted massively by this. And I it still also is considered developing science in the case of we're even trying to make more complex parts of the human. So I even see a wider adoption in the future.
So will we see in the future then, or likely to see in the recent future, pretty much every hospital nearly in the world having a 3D printer or 3D printing hall?
Yeah, I would not rule it out. Like this is likely going to happen, and that's just because of the benefits where you can decentralize manufacturing, and actually, in case of unexpected situations, you can actually make things relatively quickly rather than waiting, ordering things from halfway around the world to get there. So yeah, I think it's highly likely.
Could this also be a thing, which would be very beneficial for helping developing countries that are suffering with health issues? So essentially bridge that gap of obviously supply chains taking extended periods of time to get there due to the faulty logistics and maybe them developing countries' infrastructure. So this could, if we provide more 3D printers to maybe hospitals or other aspects of it, this could actually help people's health in the developing countries as well. And it seems like a more cost-effective solution as well.
Oh yes, I think actually one of my colleagues and friends is actually working on a project like that, where developing countries, where in West Africa, where they are trying to have like a 3D printing hall to try and solve some of the local. So this not even restricted to the medical sector, to try and fabricate things on site to try and solve like local challenges. So you're absolutely right. This is becoming widely adopted, and it will be beneficial towards a lot of developing countries.
Yeah. So, and it sounds like 3D printing has done a lot for the COVID pandemic. Has the COVID pandemic done anything for 3D printing, in the sense that has it made any recent breakthroughs or mini breakthroughs to help advance the technology any further?
Oh, so like flipping the coin a bit.
Yes.
So
Yes.
I think one of the things is, I think one of the is the way where 3D printing has actually helped. Sorry, where the pandemic has actually helped is to try and make things make the process faster, because while 3D printing is a great technology, there's still some would I say shortfalls where it's not as fast as it should be, and although you can make things, but some things, depending on the complexity, some things can take minutes or hours to make. So, but with this pandemic, there's more research going into making things faster and more reliable, and even standardization. So I think those are one of the lessons learned from the pandemic to try and improve AM or 3D printing.
Yeah, I think with key technologies, we are, well, worldwide, the changing technologies, once there's that pressure, that external pressure, you see the technology rise rapidly throughout. I think you had that with the space race because of the Cold War, and obviously the pandemic is a big factor, and which is likely to accelerate these types of technologies. So it seems like it's an important technology that's going to be like crucial for the medical industry, and will likely save a lot of lives in the future. And sounds like it already is with COVID-19. One thing you highlighted earlier at the start was obviously the reason why you kind of was attracted to this industry was the aspect of the sustainability. Now, how is 3D printing? How can it help us become more sustainable?
Okay. So I think I'll start this by saying my personal background was actually related to sustainability, where I was actually finding ways to recycle polymeric materials into more useful products. That was all my PhD was on. And so 3D printing in itself is a sustainable technique, because you're actually using the right, or you're trying to use the right amount of material for a particular application. Hence, you're reducing the waste. So to also make things or help the whole recycling process, you have things like, sorry, let me give you a bit of context. You have millions of plastic waste going into the ocean, into landfill. But now there are actually some projects that look at, for example, using developing plastic filaments from waste plastics, which can then subsequently be used to make new products. So put that in context. If I have like a waste plastic bottle, there are like shredders or machines that I can put those waste plastic bottles, I would turn them into a plastic filaments, which are then raw materials used in 3D printers to make new products. So in that case, currently you have like things where when you dispose of plastic waste, it can go to landfill, or even if it gets recycled, it's recycled somewhere else. But now with a combination of such machine and a 3D printer means you can actually use your waste plastic to make new products. So in that sense, it's also helping the whole recycling system and making things more sustainable.
Yeah, and that's so important. And recycling has been a big factor since the dawn of this century, really. But one of the key issues is at the current moment is how inefficient the recycling process is. Obviously, I think it was before 2010, what a lot of the Western countries used to do was send all the plastic waste over to China, and then you'd have someone, there'd be areas which was really bad conditions, but they would go through each piece of plastic and try to find the good bits which could be salvaged. Trying to cut that off around about the start of this decade, or last decade, should I say. So it's been really needed, because plastic has become more highlighted in the past few years, in the amount of waste that's gone into the oceans. And I think what's a really important point is not only that how we have an avenue where we can recycle more effectively, but also, like you mentioned earlier, is the fact that you can get the exact amounts of recycling plastic that you need, so there's less over waste, which that waste can be put together and then be used again. It's been one of the kind of key issues of manufacturing with plastics for decades, where you just need a certain form, like you need a certain structure, and you need and then the rest of it you just throw away. So
yeah.
This is a key factor that we need now. How would you say what's the kind of needs to be done to improve then? What other areas of sustainability can we use 3D printing for?
Sorry, it was breaking. Can you say that again?
What other areas could we use? Can additive manufacturing be used to improve sustainability apart from recycling?
Sorry, I think I might.
Hello?
Oh, sorry. It's showing my connection is unstable, so I'm just trying to.
No worries.
Yeah. Okay. Sorry. Can you hear me clearly?
Yeah, I can hear you clearly.
Oh yeah. Cool.
Awesome.
Sorry, can you repeat your question?
Yeah, no worries. So obviously we've highlighted how recycling is another factor, how additive manufacturing can improve sustainability. Is there any other avenues where additive manufacturing can be used to improve sustainability?
Yeah, so I think it's also cases where, with 3D printing, you can make like complex and lightweight designs. So, for example, if you were to think of, so one of the reasons why those somewhat complicated designs have not been made is just, it's a challenge, it's a difficult thing if you're to use traditional modes of manufacturing. So with 3D printing, it means like we can be as creative as we can whilst making like lightweight designs, like design efficient materials where only 3D printed or 3D printing can make that a reality. So in that case, you're using less materials to make such product. You're not limited by the approach or the process to make it. So in that case, it's a more sustainable product because you're using less material. So 3D printing can make that a reality because of that customization and lightweight effect.
Fair enough. And obviously one other area which we're doing research, which I found that had one industry that's been heavily impacted through by additive manufacturing is the automotive industry. They're key investors of this type of technology. Could you kind of give us a brief introduction of how 3D printing is impacting the automobile industry?
Oh yeah, so a brief introduction into how 3D printing is being used in automotive industry. So for example, I'll quickly highlight that highly customization and complexity. So yeah, from the very nature of like that or those sectors, they make like highly complex designs. However, 3D printing can help make a reality because you're not stopped from doing that. And secondly, there's something called rapid prototyping validation. So if you're to make a quick, a new design that is reasonably complex, the process of going from that initial design to a high detail full-scale part is faster, which means you're able to actually make that faster and actually carry out some performance validation and testing on time. That's one of the reasons why 3D printing is being adopted in those sectors. And from an efficient design perspective, you're making more lighter components. And I must say, if you're from in those sectors, even if it's let's say a 1 kg reduction in material, it just means that it's more fuel efficient and it's cheaper to run. So overall becoming more sustainable. So those are some of the reasons why those sectors have actually adopted the use of additive manufacturing.
Yeah, no, that's very interesting, the aspect of the lightweight materials that it can help reduce. One of the aspects of obviously, as you kind of move a bit more to electric vehicles, obviously they require a reduced number of parts compared to the traditional vehicles. So that could go hand in hand with that, as the aspect of less types of components are needed, and they can go in with 3D printing that can make them quicker and lighter and closer to the manufacturing bit. The future looks very good for the automobile industry.
Oh yeah, absolutely. Absolutely.
And one thing probably, while it's looking more in terms of efficiency wise in the automobile industry, one thing negative wise is obviously it not just with 3D printing. Obviously, AI is a big player into this and other forms of automation, but the job losses in that sector, amongst many other sectors, are quite concerning. And then the aspect of 3D printing, its effect on that, it seems like potentially it can contribute to that, as less jobs could be needed, because essentially couldn't 3D printers replace the likes of molders, welders, and casters?
Oh, so that's I think that's an ongoing debate, and there's even from a general concept as to how technology and automation would they actually. I am A lot of researchers tend to think of 3D printing is not going to replace the different modes or current modes of. It's only going to complement or supplement it.
Right.
So there's still progress to be made in the field of 3D printing, and obviously it has its benefits. So, in addition, other types of manufacturing processes also have those benefits. But so how we see it is it's not a case of it will replace, it's a case of it will complement. And in terms of jobs affected, actually, it turns out that a lot of there are more researchers going into the field of 3D printing, and it means companies are actually looking for people with this skill set to come and work with them. So one of the things is it's changing the job landscape. So the type of jobs required in the 3D printing sector is different. And now one of the aims of my project was actually evaluate the type of job profiles associated with 3D printing. So the current and future job profiles.
Wow. Yeah. Fair. That's crazy. So obviously it's the factor that is a bit more of a complementing factor rather than a replacement factor. It's a good sign for that. We look at increased efficiency, and then we obviously keep sometimes of jobs that's not completely automated. It looks like it's got a big future. Obviously, what areas do you see it else improving in the automobile industry? How else can it improve the automobile industry, do you think?
Okay, so how else can it improve? I think if hopefully when 3D printing is more standardized and faster, I see it being used from rather than just prototyping stage to more will I say mass production. So I think if you can get 3D printing to be as fast as and more standardized, I think will be even widely adopted and overall improve that. So yeah, that's how I see it.
Yeah, no worries. And obviously one of the other key players in a different industry that are using 3D printing are Boeing and Airbus in the in the aerospace industry. How is 3D printing being used to improve the aerospace industry?
So I think for every sector that 3D printing is being applied to, you always have to go back and think about these four main sectors, which is complexity, customization, less waste, and sustainability. So in the aerospace sector, it means now you can make even more complex designs. So if you have, for example, you have an idea, you can actually go from a small detail and go from that from a full scale part, which can actually be quickly tested and validated and tested. So these are ways where if you have a new design to help improve the system with 3D printing, you can actually make that a reality faster and even potentially more lightweight and more effective and efficient. So that's one of the reasons why these industries are actually adopting this technology.
Yeah, no, it sounds. It seems obviously it's impacting such a wide range of industries, and it's going to be a pivotal. It's going to be a pivotal technology across the next century. Obviously, one thing that we highlighted towards earlier was one of the benefits of 3D printing was how it can essentially make products and closer to the manufacturing, essentially the manufacturing base. Now, as we found out through COVID-19 this year, and through the past few decades of increased globalization, the global supply chain is so interconnected and so dependable. And if something goes just like that, the curveball effects that happens afterwards can be absolutely devastating. Now, and with that, so with this technology coming in, more people adopting it, especially with kind of automobile industries which source their parts from all over the globe, as it's the most cost efficient and economies of scale wise. Are we going to see less dependency on international trade and the international supply chain as a result of this technology?
Oh, I think the simple answer is yes, and we can already see that happening. I'll just go a bit deeper into the example of the COVID-19. One of my colleagues actually has a 3D printer, and she was actually able to help a local hospital to make PPEs, that's like face masks and face shields. So in that case, this actually eliminated different, would I say, the middleman, where you actually had to go to the shop to get it. No, all she did was she had a 3D printer and she got the design. So currently there are like different open source websites where you can download designs for different parts. And once you download that, you can link that to your 3D printer and make products. So that's already happening. That's decentralizing manufacturing. And we could also see that with like Brunel University, where I work, actually has a lot of 3D printers, and we were able to actually support local hospitals. So there was like a 3D printing hub where they was able to actually make parts for the hospital. So I think to answer that fundamental question is, yes, we're seeing that, and I think that's only going to improve.
Yeah, it seems like if it's only going to improve, it's going to seem, I don't know if the right time is the word type of phrase, but obviously with the likes of, there's so much dependency from people from countries like the US and China, who's a fairly heavily exporter, and the trade wars that are going in between them. This could be an avenue which major superpowers invest even further in this type of technology, because it reduces their dependency on these other types of countries, and so they can bring manufacturing more manufacturing jobs home. And I think even further with that, with this the current rise with kind of global protectionism, it seems like this could be a solution for a lot of countries that are kind of taking that avenue.
Oh yeah, absolutely. And one thing I also like to say in terms of the context of different sectors or even countries taking up 3D printing, there's been a significant rise in the sector. So in the AM sector, current in 2020, I think when I checked, it was about a $10 billion sector now, which has shown continuous rise over the years. And there are predictions where it will, I think I'm not going to quote that now, but by, I think, 2025, it's going to be in the $50 billion sector. So this sector is, and that goes to show how different sectors are actually adopting this. And for example, it's decentralizing manufacturing, where cases where you and I can actually make products. So case in point, if I needed a new phone case for my phone now, some that or even customized, I just need to go online. I can Google to find out the card drawing for this phone case. Or I can design it myself, or I can download that and make it right here there. So I do not need to go into like order it from different countries, maybe China or the US. I don't need. I can make it. So yeah, I think the widespread adoption is steadily increasing. Yeah.
So in the kind of elements of obviously you would been able to go down and download the CAD software, which obviously you can have in your own 3D printer at home to build that. How obviously will that work in the aspect of, let's say for example, we all need phone cases. So in the aspect, so you buy from a supplier the patent or the software of that, of obviously the design of that phone case, and essentially you just buy them. Would it be a case of you buy that one-off, or would we see more companies look at a more subscription-based service with the kind of products that they sell the software to?
Yeah, so I think that's a big question in the field now, and there's research or studies going into like things like protection of IP rights or designs, but the verdict on that is not finalized yet, rather. But one thing I'll also say is that whilst some designers might protect like their designs and stuff. Similarly, there are open source websites, so many open source websites where, first of all, you can go on there and download if you want. It's open. Alternatively, you can actually, if you've got a nice design, you can also upload as a, I guess, as a way of giving back. You can also make complex designs and upload it for open source use. So one of the examples was even like a face shield, a quite fancy, which was actually made available during the COVID, during earlier this year, where people could just go there and download it. It was readily available for, and last year it had thousands of downloads. So regarding protecting designs or having subscription-based services, I think that's a possibility, but I don't think it's not, like I say, it's not finalized just yet. But currently, I think platforms where you can get it for free.
Fair enough. So what would you see in the future now, obviously with how this is kind of rapidly accelerating? Do you see a world where we all have 3D printers at home and in our garage?
I think I'm close to getting mine soon, actually. So I think yes, a few of my colleagues have theirs at home, and I just need to clear out the space for it. But and the reason for that is that the machines are actually getting cheaper. Think back at 10 to 13 years ago. I think in 2007 there was a big hype when it became about $5,000. Now you can actually get machines with just a few hundred, like as low as almost £100. So it's becoming cheaper and cheaper, if not even cheaper than some conventional printers. So that makes it easier for people like you and I to actually have this and make fancy designs at home. And I was also very close to getting it, especially when the cases were very high. Well, the cases are still high actually. But when hospitals needed help, and my colleague was doing it, I was close to getting it, but I just couldn't. So answer your direct question, yes, we're getting closer where you see 3D printers in homes and garages, and I think I'm the next person to get one. Yeah.
Fair enough. They do seem quite exciting to have the aspects of how much you can make. And obviously, how does it work with obtaining the raw materials that you need, obviously, to put into the 3D printers? Obviously, I imagine that you need to order these online, or you need to go out and buy these essential raw materials that you put in, which the 3D printer uses to manufacture.
Yeah, so a lot of this, like the most common one being extrusion, so which means that a lot of the raw materials are in form of filaments, like plastic filaments, and these are readily available. Like the same way you order different materials on Amazon, for example, you can easily go ahead and just order 3D printing filaments or from the manufacturer's website. So it's readily available. So and that's why people are adopting it. So
yeah, no, that's quite interesting, because there's so much it can be used for. Obviously, kind of examples that we've kind of touched upon there being kind of small scale products. Is there do you see a world where in the future, when we all have these 3D printers at home, that we can essentially make parts for bigger products? So if it can be essentially maybe use, if there's metal or an aspect of that, to help build up parts, and then we can make a bed at home. Do you see a world where we do that?
Oh yeah, why not? Like I think a lot of the answers to the questions about 3D printing is why not. But bear in mind that you're often limited, depending on the capability of the 3D printer. You're often limited to the size at which you can produce parts. So a way to go around that is to make when I say modular, like a modular system where you make different bits and parts and they can be assembled together. So so that's the limitation with that. But if you've got a 3D printer with a bigger platform, you can actually make materials that have greater size. So I think the only limitation there is the build platform.
Yeah, no, fair enough. Like what we've talked about, we've gone through so much in around about 40 minutes. One thing, and we've discussed these ridiculous kind of things that 3D printing can do, and essentially revolutionizing technology. could this be have as a big impact on humanity as the internet did? Do you think?
I think that's a good question. Yeah, like it could, indeed it could,
Yeah.
and you have like the internet. A lot of it, I think I think the internet has done more good than harm, but you can't always rule it out that it could be used for things that are not right.
Yes.
And that's the part where potentially you mentioned people making guns from 3D printing. So that's in principle is a possibility, and you can provide different parts of it. So at the end of the day, we always have to have that ethical mindset to ensure that this is like, even though yes we can do this, we need to make sure we're doing it the right way. Because yeah, so that's yeah, it could that's a mindset I would recommend we all should have, having that ethical consideration behind developing new product.
Yeah, I think that's a very good point to kind of highlight as well. I think with any kind of revolutionizing technology, it's going to come with the good and the bad. If we talk about
Yeah.
obviously the aspects of obviously aerospace travel, obviously that accelerated us to be able to go from different around the world quicker. Obviously created certain types of weapons, which obviously are not great. Same thing with the internet. The internet is allowing me and you to be able to speak now. Literally a rate like 100 miles away, and has created so many jobs and been able for people to connect ridiculously. And then obviously it's had other impacts as well, which are negative. So with any kind of revolutionizing technology, there's always going to be the good and the bad that comes with it. And I guess when people who are close to the industry like you, to hear that the ethical concerns of this technology are quite of a high ranking is comforting to hear, because I think with the creation of the internet, I think a lot of people, it was this new type of technology and everyone was kind of getting new to it, and no one knew about the genie in the box. Obviously, once you get the genie out of the box, it's hard to put it back in. So this time round, it's more comforting to hear that the people that are focusing on this technology do have these concerns in mind, and that we've learned a little bit from our previous history.
Yeah. I couldn't agree more, and that's right. I think even there are some institutions where within the research field where you always have to carry out like what's it called? It's like, I've forgotten the name, but it's essentially an ethical. You have to submit an ethical you have to get an ethical approval before going ahead with certain projects, and that's just like you said with anything. It could be used for good and bad, and hopefully we all hope that it can be used for good and to help make lives better, to make things more efficient, make designs more sustainable. So that's the concept we have in mind.
Yeah. Who would you say the key players at the minute in this kind of overall that are developing this code? I know we talked about a few people in specific industries earlier on, but who in general, who would you say are the key developers of this technology right now?
Oh, sorry, do you mean the sectors?
No. As in general as a whole, because we've talked about a lot of universities using them. Are there specific private enterprises that are developing this technology, and it's their kind of form enterprise? Because you mentioned earlier that in 2025, this is scheduled to be a $50 billion industry. Now, obviously, there's going to be a lot of people, a lot of firms wanting a piece of that pie. Who do you have any idea who the big firms are that are advancing this technology at the minute?
So I think regarding naming specific firms, I think well, you've got the likes of like Stratasys or Materialize utilizing developing and utilizing this field. But I think what's more, would I say, a better answer to that question is like, for example, different unique sectors using this. So you have things like the fashion industry, the food industry. So you have like 3D printed pastries now, and this stems from the where customized pastries with complex designs utilizing this, and you've even got it being used in the construction sector. Although that still develop and needs to be finalized. Like a case in point was in China, for example, you had like 3D printed quarantine booths for patients, and this was done from that technology. So that goes to show how this technology can actually be applied in an array of different sectors. And for the future, I would say, whilst you have the medical, the automotive, the aerospace, construction, food, textile, fashion, I think more sectors can still apply. But I'm not sure, it's hard to say which one will have the bigger slice of the pie, so to speak. But I think a lot of firms and industry are on the thing, regardless of what they're making.
Yeah, fair enough. So obviously one of the things that's I'd like to ask you as well, because you're so close to the industry, what are the key barriers that are preventing the advancement of this technology right now?
Oh, I think that's a very good question, actually. And there are different things that are affecting the, will I say, widespread uptake. There's the, first of all, is cost. It's cost, and there's the speed. So relatively speaking, to make different materials, it might be more, if you were to make a lot of them, it might be more efficient to use like things like injection molding or extrusion to make them. So if 3D printers are made to make products reasonably faster, I think that would lead to greater widespread. And there's something, there's also the cost as to which the cost of equipment actually reducing over time. So if it further reduces, I think that will also lead to its widespread uptake. And there is standardization. So different parts can be made with different materials. So you need to ensure, actually, AI is also being used in collaboration with 3D printing, where sometimes you can actually scan defects or something in products, and you're able to estimate how good the product is, essentially. So you need to ensure that each product made is the same and doesn't have like bad features in them. So in case of standardization, I think if we were to find a way to standardize the process, that would actually help its greater uptake. So yeah, I think those are like the three main points I have in mind for that.
Yeah. And when I was doing a bit of research, one of the things that I found was one of the barriers is the different aspects of CAD software that are used, and which essentially sets back engineers, because instead of just having one plain forward type of software, they have to know different types. Now, if these types of software could be integrated and they could just create one to move forward with, surely that would essentially accelerate the progression.
Oh yes, so that is that's a valid point. However, I've made there are things where you can actually convert into specific or universal wide formats. For example, like there are some things regardless of the software you use. A lot of softwares you can actually convert to things like the STL file, which different 3D printers understand, and you're able to make products from there. So having that, there will still be different software that can make designs, but being able to convert it into a standardized format. There are different standardized formats for 3D printing, but STL file is quite a popular format to use, where regardless of the software you use, you can actually get a consistent format which the machine understands. And also, I've actually just remembered one other barrier which I forgot, was the lack of skilled professionals in 3D printing. So although the technology is developing at a very fast pace, we don't currently have enough skilled professionals to do to work in the 3D printing sector. So that's actually a challenge. So one of the objectives of my project is to try and understand what the skills are and how to actually train people to be developed or to have such skills to be able to work in the additive manufacturing sector.
What type of the skills then will people need to enter this market? Because if anyone's listening and is interested in the subject, and maybe looking to take this as their potential future career path, like yourself, what type of skills do they need to have? in order to
Yeah. So
be successful in this industry?
yeah. So it's a combination. Will I say it's a multidisciplinary skill set.
Yeah.
So what you have now is a lot of people that work in the AM sector have a unique skill, maybe in just the machines or in the material. So, but what will really set you apart is to have an understanding of different factors of additive manufacturing, and for example, being able to identify the best process or the best AM process to design to make a product. So you have things like the additive AM design and modeling software. So this involves like CAD design, being able to use CAD designs or optimization. You have different materials being used in AM. So you need to be able to understand these different, which includes like the properties like metals, plastics, AM processes. I mentioned like the 7 different processes of AM. All of them have their different advantages and disadvantages. And being able to use for example, the equipment and software, AM inspection and standards, and post-processing options. Like after it's done, how do you make it nicer? Or for example, the life cycle analysis. So it's more an understanding of this broad set of different skills that will make you stand out and unique to employers.
Yeah, so that's obviously, it seems like there's a lot to cover there, and obviously it's a very difficult industry to essentially learn everything from. Obviously, you just mentioned earlier is the aspect of like there's not enough skilled people. So in regards to the 3D printing job market, I imagine the opportunities are there. There's just not the supply of people going through.
Absolutely, and this also relates to one of the things my project is trying to solve. For example, there's now a development of new job profiles in the AM sector. So you have like job titles, things like AM designer, AM materials engineer, AM process engineer, AM inspector, AM operator. These sort of roles and did not exist previously. So now you're getting employers refining the skill set they want, and this is changing the whole job landscape in the additive manufacturing sector.
Yeah. Do we see, I guess obviously a big gap of that as well, obviously because the technology is still so very new, is obviously the lack of obviously how the aspects of additive manufacturing in the educational system. So that could go down to obviously it needing to be taught more at at high school level, and then I imagine, I don't know if they already have this, but surely in maybe the near future, for the demand for these type of skills and jobs are needed, universities create specific additive manufacturing courses.
Yeah, absolutely. So actually the title, I don't know if I mentioned it earlier. The title of my project is actually called Sector Skills Strategy in Additive Manufacturing. And one of the major deliverables of that is to make an international qualification system for AM. Right. Essentially, if you needed to gain these skills, you're able to go into different institutions that cover this qualification and learn and develop those skills, because currently there's a lack of it. So what you see commonly, maybe there might be modules or even subsets of modules which covers AM, but AM in itself, it's a very broad field, and that's one of the things. So at the end of this project, we would have like an international qualification system in additive manufacturing, whereby if people needed to have qualifications in that field, they could go ahead and do that.
That's fantastic. Obviously, it helps bring it all into one rather than kind of going through the experience that you had through learning different avenues, and then essentially being more kind of a narrowed way to kind of to get to the end result. For anyone who obviously may be listening, maybe this might be the way they want to go and take their career. How would you recommend they start that path? Oh,
so if you're looking to go into AM, so firstly, there's a I guess I'm obliged to first check out my project website, which is SAM project. I think it's called Skills for EU. Yeah, I will need to double check that, so you can check that out. But regardless of that, there's a plethora of different sub courses online where you can just go ahead and check, for example, start from the basics. What is AM? What are the different processes? What are its benefits? I myself have carried out, I've organized different webinars and giving out lectures on AM. So, and there are many more. You can actually join webinars based on the current situation. There are more and more free webinars you can attend. So if you have some, there will be some that will give you that overview and pathway to get into the field. But yeah, I strongly recommend it. And I would say, yeah, start by the basics, by going through these online courses or even YouTube videos.
Yeah. Fair enough. I'm happy to share the link with this video if you want to send over your project.
Yeah.
And so, get it out there for anyone that might obviously want to look a bit further after hearing this.
So it's skills for AMEU. Sorry.
Yeah.
Skills for AM.eu. I've just double checked.
Awesome. Fantastic. One thing I did, obviously, it was one of the examples that I had written down, but I forgot to mention earlier. It kind of refers back into the aspect of the sustainability of additive manufacturing. So we talked about the aspect of it improving an efficient recycling system, obviously helping make lightweight products. One interesting story that I found, and to just be able to kind of check your opinion on the validity of this, is that there's a Cambridge student that set up a project to essentially make coral reefs out of through 3D printing, which seems like a fantastic. These type of 3D this type of coral reef that's made through 3D printing is being able to be made and be compatible with the type of algae that obviously that is needed for coral reefs. So, would you say that's it could venture into that kind of world, or do you think that's still quite very unlikely or very far ahead?
To be completely honest, I've actually heard of that, or not come across it, and I think I will check it out after this. But in principle, where you have AM being used to make from like living tissues and cells and biomaterials to make, will I say, very complicated parts of human, complicated human parts rather. I think I would not say no to that. I would say it may be possible, although I will need to look further into that. But yeah, one of the, will I say, the selling points or the key factors of 3D printing is that complexity and customization, and you can use it to even make complex human parts. So I'll need to have a second look at coral reefs, and
fantastic.
So I'll reserve my opinion on that for now.
Fair enough. And then I've just got one last question. I asked this to everyone, and it's kind of a nice way to end the show. If you could give one bit of advice to anyone about anything, what would it be? It could be completely focused in additive manufacturing. It could be general life advice. What would it be?
Oh, that's good. That's a good question. I would say, don't stop learning. I think one of my favorite quotes is, the more you know, the more you know you don't know. So the more you know, the more you realize, oh, there's so much more to know. So don't stop learning. There are always new things to learn. So that would be my advice.
Fantastic bit of advice. It's something that I also agree with fully. Never stop learning. It's one of the best things. Right. Fantastic. Thank you, Addie, for coming on and discussing this very interesting topic. It's been a pleasure to have you on. Thank you very much.
All right, no problem. Thank you, Harris, for having me on, and we'll speak again soon. Thank you.
Fantastic, always. Thank you. Thanks for listening, guys. If you enjoyed it, give it a like or a 5-star rating, depending on what platform you're using. If you want to find out more content from HP Talks, subscribe to the channel. From here, you'll be able to see all the content I released for season 1. If you want to support the channel even further, head over to my Patreon at HP Talks. I'll put a link for that down below. Cheers, guys.